Hi everyone, welcome back. In this next video, I'll describe how to find where a line intersects with a plane. So I'll begin by drawing a picture. And this picture is not going to actually help us find the answer, it's just going to help us understand what is actually being asked. Here's a piece of a plane. And then above this plane, I will draw a line that does not intersect with the plane. Oh. So what's happening is that this line is parallel to the plane, but not in the plane. So imagine a sheet of paper with a pencil hovering just above it. And that pencil is not angled towards the plane or away from the plane, it's just straight above it, going left and right, forwards or backwards, whatever the direction is, but not ever in an orientation that will cause it to eventually intersect that paper, no matter how long the paper is and how long the pencil is. What would happen if you were to angle that pencil, to give it any angle, or angle that paper, or angle your desk, or whatever the surface is, those two objects would eventually intersect. They would eventually touch each other if they extended forever in all directions. So that would be this picture. So here they go, they crossed. What I'm getting at is that not every single line intersects with every single plane. Sometimes there is no point of intersection. When you're asked to solve questions inside this course for homework and on tests and on quizzes for marks, you'll be asked these types of normal problems where the line actually does intersect the plane. But in general, if I make up a random line and make up a random plane, I may accidentally make one up where the line and the plane are parallel to each other and they will never intersect unless that line is actually on the plane. Anyway, so how do we do this? I'm not going to read that, I'm just going to show you. I want to find the point where the line described by x of t is equal to 101 plus t times 321 intersects with the plane described in standard form x plus y minus 2z is equal to 3. What does intersect mean? Intersect, you know what, I'll go back to that picture. Oh, I erased the picture. I gotta draw it again. It's so important. This is the last video with pictures in it, I think. Or the last week with pictures in it. And then there's more pictures. Okay. So I'll call that point where they cross, I'll call it Q or P or R. I'll call it R. They intersect at R. And if they intersect there, it means they share the same x, y, and z coordinate. These objects have, so the line and plane have the same x, y, and z coordinate at this point of intersection. So if you knew what the x coordinate was for the line at the point of intersection, it has to be the same x coordinate for the point of intersection of the plane. I mean, that's what it means for them to intersect. They share the same x, y, and z value at that point. And that is actually all that we need to solve the problem. To acknowledge that if two geometric objects cross, if two geometric objects intersect, the x coordinate for one is the same as the x coordinate for the other. The y coordinate is the same as the y coordinate. The z coordinate is the same as the z coordinate. I'm going to put this line into parametric form. Put into parametric form. So parametric form says that x, the first component, is equal to 1 plus 3t. Y is equal to 0 plus 2t. And z is equal to 1 plus 1 times t. So it's telling us what the x, y, and z coordinates are for the line in terms of this parameter t. The plane is written in standard form in terms of x, y, and z. Well, I can force these two objects to cross if I substitute sub into the plane equation x equals 1 plus 3t, y is equal to 2t, z is equal to 1 plus t. This forces them to cross. It says, okay, the x coordinate that you have, guess what? I'm going to give you the same x coordinate as the line. And the same for the y and the same for the z. I'm going to do the same thing. Now, hey, you got no choice unless the next thing that we do yields no solution. So I'm going to plug those in and see what happens. We have x, so 1 plus, I'll write down the equation, x plus y minus 2z is equal to 3. So we have 1 plus 3t plus 2t minus 2 times 1 plus t equals 3. So I just substituted those three things in. Now, the x, the y, and the z are gone. We only have one thing left, the parameter t. Let's see what happens. 1 plus 3t plus 2t minus 2 minus 2t is equal to 3. We have to collect like terms, so the constants can all be collected together. 1 minus 2, I have a negative 1 on that side. And then 3t plus 2t, 5t minus 2t back to 3t equals 3. Then I can add 1 to both sides. So 3t is equal to 4. And I get a solution that t is equal to 4 over 3. Okay, now, that's not the point of intersection. That's something we need for the point of intersection, but we're not quite done yet. Our next step is we have to see what this means for x, y, and z. We put this back into parametric form for line. So we have x equals 1 plus 3 times 4 thirds, which is 1 plus 4. The 3's cancel top and bottom, which is 5. Y is equal to 2 times 4 thirds, which is 8 thirds. And then z is equal to 1 plus t, so 1 plus 4 over 3. We need to make a common denominator, so 3 over 3 plus 4 over 3, which is 7 over 3. So our point of intersection is 5, 8 thirds, 7 thirds. We could check that. We could plug that back into the original expression for the plane. Make sure that left-hand side is equal to right-hand side. So I'm going to quickly do that check up here, then I'll erase it. So someone looking at the video later is not going to wonder what that means in the middle. Like, they'll get confused. So x plus y minus 2z is equal to 3. So 5 plus 8 over 3 minus 2 times 7 over 3, so 14 over 3 equals 3, question mark. So 15 over 3 plus, let's see, 8 minus, so let's see, 14, 6. Oh, I didn't need to make common denominators. 5 minus 6 over 3. is equal to 3, question mark, 5 minus 2 is equal to 3, question mark, yes, 3 is equal to 3. So this means that our calculation worked. And we know for certain it is a point on a line because it just comes from replacing t with a particular number, changing our parameter to a particular choice of t. So I'll just circle that as the final answer. Okay. And they're all pretty much done that way. I guess I'll point out one possible difference is what happens if the plane is not written in standard form. What if it's written in point normal form? Well, you'd have to convert to standard form and then do this. Likewise, if the line is not described in point parallel form, maybe it's described in 2-point form, I'll first go from 2-point to point parallel and then put it into parametric. So you always want to follow this template for getting the point of intersection between a point, between a line and a plane. But you may have to do some steps beforehand in order to get to the initial format that this question was given in. The line is in point parallel form and the plane is in standard form. So keep that in mind as you're doing these. The other type of intersection we can have is the intersection between two lines. In the first example, we have the intersection between two lines in 2D. The first line, x of t is equal to 3, 1 plus t times 2, 1. And the second line, x of r is equal to 0, 1 plus r times negative 1, 0. So I'm going to convert both into parametric form. Convert both lines into parametric form. And it's also worth, before doing this, just making sure that those direction vectors are not parallel to each other, that one is not the scalar multiple of another one. Because if these are two parallel lines, and they're different lines, like they don't share the same point, then they will never intersect, and it's pointless to go through the process. So 2, 1 is definitely a different direction vector than negative 1, 0. These are not parallel lines. In 2D, that guarantees that they will intersect somewhere. So we will find a solution. Anyway, so we'll convert both of these lines into parametric form. We have the first line, line 1. Our x coordinate is equal to 3 plus 2 times t. Our y coordinate is equal to 1 plus t. And then our second line, line 2, our x coordinate is equal to 0 minus r, which is negative r. And our y coordinate is equal to 1 plus 0t, which is just 1. If these lines intersect, then at that point, we must have the following. We must have that the x coordinate of 1 is equal to the x coordinate of the other one, and the y coordinate is equal to the y coordinate. So if x is equal to x, that means that 3 plus 2t is equal to negative r. And if y is equal to y, that means that 1 plus t is equal to 1. So what does that tell us that t is? So this says that t is equal to 0. 1 plus 0 is equal to 1, or subtract 1 from both sides. We could go back and find r, but we don't need to. We're actually done. We can find the point of intersection. Well, I'll just do it quickly. So 3 plus 0 3 plus 0 is equal to negative r. So r is equal to negative 3. We didn't need to do that. All we needed to do was take our t is equal to 0 value and plug it back into the parametric form for line 1. Replace t with t equals 0. X is equal to 3 plus 2 times 0, which is 3. Y is equal to 1 plus 0, which is 1. So our point is 3, 1. That's our answer. Now you're asking, you should be asking to yourself at least, why didn't we do anything with R? Like, this looks like it's half solved. Well, I'll show you what we can do with R. It's not necessary, but what we can do is we can check. Double check. Try and make this sensible for anyone looking at the note, not the video later. Double check that R equals -3 plugged into L2 gives the same point. So x equals -r, which is -3, which is 3. So far, so good. And y is equal to 1. So yes. We didn't need to do that. We didn't also need to plug in t is equal to 0. We could have found r first and then just plugged in r for the parametric equations for line 2. Not dealt at all again with the parametric equation for line 1. We'll do one more example, this time in 3D. Finding the point of intersection between two lines again. Start the same way. We'll write both equations in parametric form. If my computer doesn't mess up again. So the first equation is that x equals 3 plus 2t. This is line 1. Y is equal to 2 plus t. Z is equal to 1 minus t. And then for line 2, we have x is equal to 1 minus r. Y is equal to 0 plus r, and z is equal to 3 minus r. If they intersect, then at that point we will have x equals x, y equals y, z equals z. So the first equation, x equals x, that equation says that 3 plus 2t is equal to 1 minus r. The second equation says that 2 plus t is equal to r. And the third equation, the z equation, says that 1 minus t is equal to 3 minus r. This is called a system of equations. It has 3 equations and 2 unknowns. There's many different ways that we can solve these. We can use a process called substitution, or we can use a process called elimination. That's all we know right now. Soon we'll learn another method or another group of methods for solving systems like this. I'm going to use substitution because I think that's what the majority of students are comfortable with at this stage. What they learned in high school, grade 9, grade 10. Substitute sub r equals 2 plus t into the first equation. Okay, so what do we get? We get 3 plus 2t is equal to 1 minus bracket 2 plus t. So replace that r with the 2 plus t, because that's what equation 2 says that r is equal to. Now I'm going to distribute that minus sign on the right hand side. So 3 plus 2t is equal to 1 minus 2 minus t, and then collect like terms. So 2t, I'm going to add t to both sides, so I have a 3t here. Then I have a 3 plus 3t is equal to negative 1. I'm going to subtract 3 from both sides, so I'll still have a minus 4 on this side. Now I'm almost done isolating for t. I'm going to divide both sides by 3, so t is equal to minus 4 over 3. Now we plug that back in. Plug into parametric for line 1. Notice that we have to plug it into line 1 because line 1 is the line with t, the parameter t. We can't use the value of t as the value of r in the other line. It only is the value of the parameter for that first line. The second line will have a different r value. They'll have the same coordinate at that r value. That's the whole point, to find where they intersect, but it'll have a different parameter. Just watch that. Make sure that you put the parameter into the right equation. It's not a choice. You have to do the right one. Okay. So when we do that, we have x is equal to 3 plus 2 times t, which is 3 plus 2 times negative 4/3.